So let me welcome you. It's the coffee lecture from the Chemistry, Biology, Pharmacy Information Center. My name is Jozica Dolenc. I'm heading the Information Center here. And today I will talk about inorganic crystal structure database. So what is this database? It is the most comprehensive, the biggest database of fully determined inorganic crystal structures, including pure elements, metals, minerals, and other inorganic substances. As you can see on the picture below, the majority of crystal structures that are in the database is experimental. Now, since 2017, they also include some theoretical inorganic structures, but under very stringent criteria. And since 2018, they also include some metal organic structures. So it's not only inorganic structures, but those metal organic structures must have inorganic applications and relevant material properties and so on. If you are interested in pure organic substances, then that's not the right database. Then you must look into the Cambridge Structural Database. And as you will see, the two databases are also linked together, as well as with the Materials Project, which I have shown last week. So again, the picture below, you can see now the numbers we have at the moment, over 335,000 crystal structures in this database. Per year, about, I think, 10,000 to 12,000 structures are being added. So the database is growing all the time. Now, maybe a word about who provides this database. This is Fachinformationszentrum Karlsruhe. The database is not open access. It's a paid database, and Infocentrum is actually licensing this database. Now, from here on, I will now not talk anymore. I will just give you a live demo. So let me go to this screen. This is now inorganic crystal structure database. If you're at ETH network, you just go to the address I just showed you before, and then you can use it. You don't need to log in. You can use it directly. Now, let me show you a couple of examples. I searched for the first crystal structure, which was determined in 2013 by William Henry and William Lawrence Bragg. I think we know them. So let me try to search here in the basic search and retrieve for authors. And let me put in Bragg and maybe 2013. And let's see what happens. When you want to run a query, now it gave me even a suggestion. So I take this one. This is even better. So there are initials. And then when you want to run a query, you go here to the right-hand side and click on Run Query. No results for the search criteria, that is. Of course, it's not 2013. That's wrong. It was 1913, like that. That should work now. I'm doing still something wrong. Let me remove the year. Maybe it's published somebody at some other time. Authors, bibliography. Now I can't see the problem. Let me clear the query and do it again. Bragg. I want them. Run query. Okay. It's a very good example. You can see here on the left-hand side, content selection. I was testing some examples before starting the coffee lecture, and I was checking theoretical structures. So you have to watch out. Even if you make clear query, it will not clear the content selection. Yeah, so here, Bragg didn't do theoretical structures. They were really measuring. So I should go and search for experimental inorganic structures. Now that should work now. Let me go again. Bragg and run query. Yes, now we have them. So the two crystal structures, which were determined first by X-ray diffractions, are here in this database. And then if you want to look at them, you click on the code. Here then structure formula, structure type, and so on. So let me show you sodium chloride. And this is now how the entries in the ICSD look like. So you have here summary of the structure, you have visualization, you can click on interactive visualization, and there, for those in the room who would like to explore cells, you have here a possibility to explore coordination, unit cells, measure distances, and so on and so forth. I'm going to show that also later. So you can do a lot. And here are then powder patterns. These are simulated powder patterns. So if you want to do more, you can go here and say, I'm interested in a different source or different wavelength. You can visualize it and so on, and also export the pictures. So this is a typical entry from ICSD. Here then see the chemistry, published crystal structure data, standardized crystal structure data. And then you have here the possibility to also measure and do statistics on distances and angles. Let me just show you now. For example, I'm interested in a pair of elements, sodium and chloride, and at a distance, obviously. And I can then do a histogram, and it tells me what is the distance between sodium and chloride in this crystal, and then how this is distributed over the whole ICSD database. So these like very simple statistics are also possible. Then there's biography and some more details about experiment, how it was done. One more thing I forgot to mention, with very many structures, you have here this see also possibility, where you can click on the first link and you get a connection to Cambridge structural database. Yeah, so in this case, we have it there as well. Or the second option, which sometimes exists, is the materials project link, what we've seen last week. So these are then the data which have been calculated within the materials project. Yeah, so this is then, here you then get many different properties than in the ICSD. So that's just in addition to everything. Now I'm going to go back to query. So that was now a query where we were searching for authors. I wanted to show you that was one of the first, it was the first crystal structure. The diamond is also there. Now, usually you have an idea about the composition. You search for specific chemical composition. And if you want to do that, basically you type in the elements. So I have here an example. And now we'll now still focus on experimental inorganic structures. So that's what you can do here. And then you can say, yeah, I would like to have maximum 3 elements and maybe primitive centering. And you can add more information if you like, and then you run a query. So this is how it looks like if you search by composition, and then we will get now many more hits. We got 203 hits. And here you can then see different hits. And as before, you can click on the ID to look into the structure. Now these are now a little bit more complicated. And then also all this gets more interesting, yeah, and unit cells and so on. But the structure of the entry is always the same. Just quickly show you how it looks like. And here you then also have possibilities to calculate distances and angles, and so on. So that is an example of a one compound. Now, if you would like to say, yeah, but actually I'm interested in this structure and how it compares if I have platinum instead of palladium, you can also do that. You can select both, and then you go and compare structures. And then you can have a look what is the difference. And here you would see there's not so much differences, but you can check then the details, or you can compare powder patterns. So that is also possible within this database. Good. Checking my time, I go back to the query. So I showed you this part now with inorganic structures. Now, if you are interested in metal organic structures, you just tick that box. And I will now say, yeah, let's look at palladium. I will remove that to get some more results, and we run. And then you get here now metal organic structures. And these are then also, like before, one can look into them. They get more complicated. And I think this is really very helpful to look then into details of what's going on here. Good. Similar is then for the computational structure. So I will not go here. You can check yourself. You do the same thing. Then next to this basic search and retrieve, we have here then advanced search and retrieve fields. So if you have specific ideas what you are searching for, specific journal, specific article, you can start here just with bibliography search. Then you have a possibility to search with cell parameters, with more specific chemical information. You can go also for mineral names, mineral groups, and so on. Then you have symmetry search, again, with very many different possibilities. You have structure type search, you have experimental information. So here, if you have a specific temperature, specific pressure that you would like to look at structures so that those conditions, you can search for them. And you have also then expert search where you can build your own query and combine different words. So that's it. And then basically under managed queries, you can like, if you had many different ones, now I didn't do so much of that, you can combine with yes, no operators like with every other database. And that's it. I am over my time already. And so I will stop this presentation and I quickly show you the coffee lecture card in case you would like to download it. I prepared it and here's a link. So this is just a very small summary of what ICSD is. And I think the most important takeaway message is if you're searching for inorganic crystal structure experimental ones, that's the main source. Exactly. And with that, I'm finished. And I would like to invite you to our last coffee lecture from this coffee lecture series, which will be given tomorrow by my colleague Emmanuel Mayer. And he will present a tool that is licensed by the ETH library and it's called Cite Them Right. And this is something what is very useful if you have to write something short where you don't need reference managers, but you need to cite web pages, books, articles, and you don't know how to do that. So in this tool, different citation styles are covered and it tells you then how you do that. So you don't need to open a big library in EndNote to cite, and the students, I think, like that website a lot. So that's going to be presented tomorrow. And with that, I'm saying goodbye. I'm open for questions and thank you for your attention.